You will find out soon in the next 60 minutes that I'm not a huge fan of pie charts, and I will show you why and what ways you have to better visualize your data. So I always like to share this short video of a coffee machine in the school I'm teaching at. So they have this coffee vendor machine where you can get your coffee, and then there's it in a huge screen, and on the screen they put like this visualization, a pie chart or a ring chart, showing the progress of filling your cup of coffee or tea or chocolate. And I find it really funny because at least in this window machine, the cups do not feel like in circles, but they feel like from bottom to top. And I'm always wondering why they didn't use a column chart for showing like the column is filling up from top, from bottom till top, but they use the pie chart. So pie charts are everywhere, but I don't really think they are the best way of visualize data. My name is Markus Ehrenmüller-Jensen. You will see my contact details at the very end. So if you need like the examples, the demo files, or have any questions, please do not hesitate to reach out to me and the contacts at the very end. As you can hear from my accent, I'm not US, I'm not coming from the US or UK. I live in Austria. And sometimes it's hard to explain people where Austria is. Even CNN had a problem with make a difference between Australia and Austria. So they announced once Australia building fence at Slovenian border, but the truth is Austria built a fence at the Slovenian border, and not Australia, which is far, far away. Austria is in Europe. So no worries if this happens to you. Even the best are, even the best can have this problem in confusing Austria and Australia. So the agenda for this 60 minutes is rather short or rather clear. So the first thing I will show you is the good, the bad, and not the ugly, but the pie chart. And then I will show you 5 rules, so a handful of rules, which you can use to improve your data visualization. So check them out. I'm starting with the good, and I want to keep this interactive, so I'm not sure how many people will answer to my question here. So why would you think, or why do you think that I'm thinking this is a good visualization? Any responses to this question from the attendees? If not, if you watch the video later, then make a short pause and think about what could be good there. So what I think good there is that we have like two measures, the amount and the percentages. We see a smart visualization, like the discount amount for North America is the highest because the bar is the longest. We see there's some obviously problem with the discount percentage with Pacific. So this is with red background. Yeah, we get a clear overview, and even if you don't read the numbers, we get an overview about how high or good the numbers are, and if we need the concrete numbers, then we can read them. The bad example is like this one. It's a ribbon chart. I found something similarly on the internet. So some vendors of visualization tools brag with their what I think not so good visualization. So I rebuilt this one so I don't get any conflict with copyright issues. So rebuild this in Excel, and now it's your turn to think about why do you think that I think this is a bad visualization. If you watch this later, then you can pause now. Other than that, I will explain what I think is really bad. So we don't know what this is. There's total at the very top, but we don't know total about what. It's hard to see. Then this is a ribbon. This is like a 3D line, which makes it really confusing. And then we see, if you want to compare the value for Europe to the value with Pacific, I really have troubles because of this 3-dimensional room. It's really hard to see how many lines and gaps are between Europe and Pacific, for example. And in the legend, we see Europe should be blue and North America red and Pacific green. And we don't see anything blue on the visualization because this ribbon starts at Europe and leads to North America, and then the color for North America is used, and there's nothing blue there for Europe. And of course, a line chart using for categorical data is a bad idea because there's no connection between the values in Europe and North America and Pacific. So there's no linear change from Europe to North America in any numbers. So it doesn't make sense to connect Europe and North America and Pacific with each other. And finally, the pie chart. As I'm talking about pie charts, of course, I have to show you a pie chart and later will convince you not to use them. So what do you think is bad and not so good with this pie chart? Any responses from the attendees here? Other than that, you can watch it later again and pause here before I explain what I think is bad here. One obvious thing is that we have a pie chart which should be sum up to a whole. So you would expect that 1 or 100% is the total of the numbers, but when we look at the numbers, 1.79 is the green area for Pacific and 0.94 the blue area for Europe and 0.58 the red area for North America. They do not sum up to 100% or to 1, so this is really confusing. And it's a 3D pie chart. We will later see a similar pie chart, and then we will see that it's really hard to compare stuff in a pie chart. So there's a rather small amount of use cases, very narrow use cases for pie charts. If you miss out the rest of the talk, this is the very summary of the whole talk. So why do we visualize data? The thing is that people in organizations, they have to take actions. They have to derive actions from insights on the one hand, on the very end. And at the beginning, there's data. But data, when I started my career in business intelligence, it was not even called business intelligence 25 years ago, then having data and saving and storing data and comparing data and getting access to data was really, really difficult. So there were no tools. It was expensive to store the data. Everybody can remember the year 2000 problem when people did save the year only in 2 digits. So only the last 2 digits and not the century, because storing data was expensive and you would like to save every byte and bit you could save. This was those times. Now we don't have the problem anymore. So we even speak of big data in the sense of lots of data and data which changes fast and complex data. And it's really easy to store data in a big data cluster, for example. So nobody will throw data away. You just store it in the big data cluster, and if you need to analyze it, then you transfer it from your archive from the big data center over to another tool, and then you would like to drive any insights. The problem we have is that data itself is not very useful. So 1,234,567.89. What? So we always need a context before we can get a picture what this data is about. If I tell you this 1,234,567.89 are the sales for a certain product in US dollars for North America, you get a certain picture. And if you are familiar with the domain of the sales of the products, then maybe you can even say this number is high or low, and you can relate to the stuff. So that's how we get the picture. The other thing is pertinence. So maybe if this is sales for whole year, for whole region, for whole product group, nobody would like always tell you 1,234,567.89. Everybody will refer to 1.2 million. And this you should also do on your reports. Don't show digits and numbers and scales you don't need, but round it up and make it short and easy to read. When we have the data, added the context and applied pertinence, then we speak of information. So this is information. And where we got information, this is usually done either, if you're really lucky, you have a data warehouse. So the information sits in the data warehouse, is already cleaned up. There's a context, and so on. Then we have to present it. And this is the topic of this talk. So if you look there, I did not take a plus sign, but a multiple sign here. So what I think is of presentation is like if you take one number and multiply it by another number, and this other number is lower than 1, then the outcome of this calculation would be lower than the original number. If you take the same number and multiply it with another number, and this another number is bigger than 1, then the outcome would be bigger than the original number. And the same is true for information. If we choose the wrong sort of presentation, the wrong mode of presentation, then we will hide information. So the outcome would be lower than the original information. If you, on the other hand, choose the right way of present data, not the data, but the information, sorry. If you choose the right way of presenting the information, then the outcome would be better, and people have a really easy job in discovering the information they need. So, for example, if you say this was sales over years, then we could put this in a line chart, for example. And then people can gain an insight and see literally on the monitor, on the printout or whatever you're looking at, that the sales is declining because the line is going down, literally going down on the visualization. So this would be the insight, and then the action comes at the very end. So from data to action, and this is usually not the part project I'm part of. This is like management. They have now to decide what to do if sales are going down, if they want to increase marketing, if they want to quit the product, if they want to invest in new features for the product, whatever. This is the actions we can derive. And this is the very essence of why we're visualizing data and why we should think about visualizing stuff. And what I also think is really, really important is that you do requirement engineering. Usually people do not come to you and say, just write me a program and I will tell you if I like it or not. This would be really, really weird. But sometimes with reporting and business intelligence and dashboards, it's like that. Here's the data, build something, and I will tell you if I like it or not. And I don't think this is a good idea. So what I think is a good idea is to do requirement engineering. What kind of insights do you want to gain? What kind of actions do you have at your hand? Because it doesn't mean anything if I present you the information in a way that you can then derive an action which you will not be able to do because this is out of your hands. Then we don't have to use any time in presenting data like that. We have to present data where you can then derive actions from it. So this is really important. Why do we present data, like visualize the data, not only tables? This is because we as humans are really, really good in seeing patterns, recognizing patterns. So I'm not sure if you're familiar with the phase on Mars. This was from the Viking mission in 1976, if I remember correctly. They made a picture of the surface of Mars, and they discovered this thing here. And they said, wow, there's people on Mars, or there were aliens on Mars, and they left a sculpture reminding of the human face on Mars, and everybody was excited. And then they sent this is the original picture here in 1976. And then they sent another mission in 1998, and they took another picture in 2001, and they discovered, it was only because the light and the angle was right that it looked like a face, but indeed it's just a rock. So bad news here. But what we can derive from that is that we easily can see patterns. Not always are the patterns right, but at least it's a starting point. And when we see the patterns, then we can dig into and make more shots and more details about the picture there, and then find out if this is true or not. But we are still, even with the age of artificial intelligence and machine learning, humans are still very, very good and better than the machines to derive patterns like that. Another example would be, I'm not sure if you have seen this from the Hubble telescope. This is a new one. I can't remember the time, the year when this was made. And some people see like a head of a maybe alien. So you have these eyes, this light areas as the eyes, and the nose in between, and down there could be like here's the eyes, and this could be a nose, and there could be like a mouth down there, and this is the head. So some people see this, not everybody can see this. Or this one. So some people see a face here, and this is of course not a face. This is not even a picture of a face. This is just not so random dots. So we have like circles down there. There's clusters of data there. Then we have, this could be eyes, the nose, and the mouth. Some people even see the 5 digit here, or the X letter here, or a 7 or 4 standing on the head. So you can see pictures and clusters like that, and this is a starting point for analysis. And that's the reason why we would even build visualizations, because we're looking for patterns. Some people say, I don't need patterns. I just use the numbers because we can calculate, like in descriptive statistics, we can calculate the mean and we can calculate the standard deviation and we can calculate the correlation. And I have this example here. So I have data points which will be drawn in this empty area soon. And your task is, with the knowledge of the descriptive statistics for this data, like we know that the mean on the x-axis is 54 and the mean on the y-axis is 47. The standard deviations are here 16 and 26, and the correlation is around 0, so there's no correlation. So if x value is high or low, it doesn't mean anything for the y values. Again, you can think about what kind of patterns we could see here. Again, if you're watching the video, stop a little bit, take a pause, and then think about what those patterns could look like. And I will show you now. So these patterns could be anything. All those different patterns, like the star or the X or the lines or the crossed lines or the circles or even the datasaurus, end up with still those descriptive statistics. So they have the same mean on the X and Y axis, the same standard deviation on both axes, and there's no correlation between the points, but they all look very, very different. And this is another reason why we should visualize the data to get an impression, because depending on how this data looks like, the information would be rather different, I guess. So I came up with 5 rules, a handful of rules. And the first one is that you should always use the proper chart type. That's the first stuff we will take a look at. Then, when you have the chart type, you should think about only displaying as few information as possible, as much information as necessary. Then, encode accurately. Fourth, highlight the important things. And very last, calculate measures. So if people need some calculations, please do them in the tool and show them the numbers. Always seen people like grabbing in their pocket and take the pocket calculator and then calculating stuff there. This should not be necessary. And the principle of the rules is, after we have chosen the proper chart type, we should remove and reduce everything we don't really need on the screen. Like the screen estate would be really, really expensive. Think about that. Only put things there which really are needed to gain the insights and derive the actions. And after we have reduced and cleaned up everything, we have space for enriching. So sometimes I hear people, I cannot add this column because there's no space in the report. And then if you take a closer look on the report, you see there's a lot of lines and flashy things and icons which are not needed. If you remove them, it's rather easy to add then the important stuff there. That's what we look now next couple of minutes. So first, the proper chart type. I've chosen for this 60 minutes, I mean, there's lots of chart types out there. I've chosen those, a table, which can be or not can be a chart. I added it as a chart type here. Then, of course, we will take a look at pie chart, bar column chart, line chart, portfolio scatter, and map. That's what we see in this course. So a table. What's the thing with the table? A table is really, really good in compare individual values because you can see the precise values. We have now Europe and we see and North America and Pacific, and we see the exact numbers like 100,000, almost 400,000, 28,000. The precise values are there. What table is also really good at is that we can see both the detail and the summary. So we can add a total at the end on the last row, or we can also have totals on the end of the columns. This is very easy to do in tables. This is hard to do in visualizations. If you have, for example, a bar chart and you add the summary, then the summary would be really, really huge compared to the other columns. And then you could not see any numbers, and you could not read any numbers from the detail columns because they are so tiny in relation to the summary. We can also add several scales and units. This is also something it's really hard to do in other visualizations. You could have 2 axes, for example, but always take care if you have more than one axis that people really know what kind of axis which value is referring to. In the table, it's just easy. We add another column and we can have different scales and units there. So we have now the discount amount in currency, US dollars, euros, whatever, and we have the discount in percentage just beside it. You should only use charts if you look for patterns, trends, or exceptions, because that's what we really can easily recognize as humans with our eyes. Also relationships. You see examples then in the chart. So take a look in Power BI how we can create a table. So I have here Power BI opened. Maybe I close this a little bit to make more space for the report. And then I can, with a double click, start the Q&A visualization, and I can ask for, what did we have here? I think sales amount and by, no, we had the discount and the discount percentage. Yes, the percentage. Can we have the percentage here? The discount unit price, the discount, yes, and the discount percentage. Please give me the discount percentage by territory. So discount percentage is not working. Then I'm viewing it here by territory group. The group, I think it's group. Sales territory group, sorry for that. Here, sales territory groups. Then we have the discount. Sorry for that. Let's have a look here. Where are my measures? So I have the discount, like here, this discount amount here, and I have in the sales, reseller sales, I have the discount percentage, discount. No, I don't have the discount percentage in this demo. And then I use the, stick with the sales amount then. Let's stick with the sales amount by sales territory. Come on, sales territory group, yes. As a table, that's what I have here, this first example. Convert this to a table, and then we have the numbers here. Rather easy to create if you know the name of your measures and columns. Then we have the tables here, and this is easy. The default with Power BI is really easy. I already also did this kind of course for reporting services and other tools and Excel, and sometimes, especially in reporting services, can be not a nightmare, but challenging to get all the things right with the formatting and everything else. With Power BI, this is really easy and yeah, smooth. And let's name this table. Then with the pie chart. I promised a pie chart because the title of this talk is about pie chart. And I think there's only one single use case for pie charts. And this use case is if you want to find out the majority of two or maybe a handful of values. So if you're looking for majorities, pie charts are nice because then you see what's the biggest item there, what's more than the half, or which items, which categories are summing up for more of the half. Then you see the majority here. So if I ask you what is the biggest region here, or which one has the majority, then it's really easy to see the green one, North America. That's the use case for the pie chart. The thing is that sometimes people use pie charts for different things, like comparing values. And what I prepared here is a pie chart showing 8 different things. Let's say this is products, 8 different products. And I want you to find out which of the products is the biggest one. So I tell you, this is a thing you usually don't know about your data before you found out, is that all of those values are the same except for one, and this one has a bigger value than the others. So think about that. Again, if the people attending the live thing want to talk to me, this is a chance. If you're watching this afterwards as a recording, press pause and try to find out what is the biggest one. Usually people tell me that the first ones are the biggest ones, and this is very easy to see or think because those areas in front, because a 3D pie chart, are bigger, literally bigger than the other ones. So if I put down like those in the background, they are literally smaller because they're in the background. So the 3D effect is making it really hard to compare things here because they are hiding stuff. So information is hidden behind the 3D effect. And the other thing is So this is one, it's bigger, and the other thing is that the things in the front, they also have like this shadow because it's a 3D object. So it's even bigger. Things in the front are even bigger than in the back. So this is not a good thing. If we remove the 3D effect, maybe it's easier for you. Again, take your time, press pause and find out what is the bigger one. What we can do here is, because this is an even number and all of them are equal, except one which is bigger, we can take a ruler. And if I take a ruler, I can see that like on the top, this line is in parallel, but like down there, the line is not parallel to the ruler. So the right part of the pie is a little bit bigger than the left part of the pie. So we can derive from that the bigger one, the bigger element, the bigger product is one of those four, not one of those four. And then we can again take a ruler horizontally, and then we will see that like these two items are bigger than the other two items, because again, this is not in parallel. So one of the biggest items has to be one of those, A or B. And if we take it the 45 degrees, then we see again, this is not in parallel 45 degrees. So obviously this element is the biggest one. But this is a little bit stupid, I guess. If you build reports and dashboards and people then have to take a ruler on the screen to find out what they are looking for. If you're looking for the majority, this could be okay, because we can see, the majority is obviously this one. Even especially if I know that they are sorted, for example, that's also best practice to sort elements in the pie chart and sort them like in this direction, like clockwise. Then everybody knows the biggest one should be up there. But really stick to this rule, otherwise you would confuse people. And with that rule implemented, we can know that like those four make slightly, but make the majority. Some people tell me then, yeah, pie charts, that's not so funny. Let's have ring charts. This is much better. And I think they are making fun, because ring charts are just pie charts where somebody bit the center. So there's only a pie which is eaten up in the center parts. So we only have the ring left. So this is of course not better. And you can find out with that if I ask you again, 3 elements here, 1, 2, 3. One is bigger than the other two. So this is information you get from me, but usually not from your data, unless you have discovered it. Which one is bigger? Again, you can take a pause and then watch this and think about it. We can change it a little bit and move it like that. So it is now easier to find out which one is bigger, 1, 2, or 3. To remove the numbers, maybe it's easier. Again, take a pause and look at this before I solve this. So we have like the third or the second one. If I move it up, we can see the second one is slightly smaller than the first one. The third one is also slightly smaller than the first one. So obviously the first one is the biggest. And this is really hard to see for some people, or most of the people I met so far in my courses. So at least even those have it right, like in the pie chart or here, they're not really secure about that. They feel not safe. It's just guess, but they're not really sure about it. And for this kind of visualization, this is called the jaw straw illusion. So Mr. Jaw published a book in 1892, so over 100 years ago, telling us this is an illusion. It's really hard to compare parts of a ring chart with each other. And 100 years later, we still use pie charts and ring charts and try to transport any information and present information. I think you should not do that. I'm not sure if you're familiar with those little tracks. So I borrowed this from my son, and of course, if you're familiar with those tracks, you know all those swings have the same size. Otherwise, you could not build anything. And it's always that the one in the front looks bigger than the one in the back. And I made a small video, so I take the one in the front and move it to the back. And if the same tile now is like in the back, now it looks smaller than when it was on the front. And this is the jaw straw illusion. And if you ping me, then I can share this video with you, and you can watch it the weekend long and learn about this illusion. The other thing is, why I told you that it's easy to find out the majority of two values or a handful of values is seen here. So if you have two values and I put this in a ring or in a pie chart, it's really easy to see which one is the bigger one. So obviously the lighter one with the lighter color is the bigger one. As soon as we add up more elements in the pie chart, it's a little bit harder. Still, you can see it's three values and two are the same and one is bigger. Then you can like see that this is obviously a little bit bigger than the other than this one. And if it's even number, it's also easy to see that the majority are those two. And obviously this one is bigger than the other ones because again, this is not in parallel. But especially if it's an uneven number and the more elements we add, it's always like the same. This one is bigger than the other ones, and the other ones are smaller. They have the same size, and this one is bigger. And the more elements I add, the harder it is to discover, if you ask me. So that's why you should stick to the rule that you would not add more than 2, 3, 4, maybe 5 elements to a pie chart. If you feel really you need to see the majority, then you could use a pie chart, but do not add too much of categories there. Then people tell me, yeah, you can always like add the real numbers and slicers at the outer circle of the pie chart. Of course you can do that, but why would I then put this colorful thing in the middle? I could just use all the numbers and put them in a table. And if the task of someone is to find out the biggest value, I just show it to him. So for example, I put an arrow or a big fat red circle where the biggest number is, because we do not want to play hide and seek with our report users. We want to show what they need. And first we have to find out what they need, requirement engineering, and afterwards we have to build exactly what is helpful for them and not what is colorful or what is beautiful. That's not so important, if you ask me. So pie chart, we can go back to Power BI. I can just duplicate this thing and then make out of the table a beautiful table. Then we make it not so beautiful anymore, and I make out a pie chart or a ring chart. Here it is. Again, we see the majority is North America. If this is the task, this is one way to show it, would be okay. And Power BI also sticks to the rule that it automatically sorts the values. So the biggest one is always at the top here, and then it goes counterclockwise, and the values get smaller and smaller until they end up here again. Bar and column chart. We have a bar chart here, so bars are horizontally, columns are vertically, and it's easy to compare values with that because we as humans are trained, or by nature can compare the height or the width of a rectangle. So think about like our ancestors. It was important for them to see, oh, this is like a tall tree. Should I climb up there to grab the apple, or should I take another tree which is not that tall? Or if they met a big bear, they could say, oh, this bear is like bigger than me. I gonna run and will not fight him. So this was important. Circles in nature are really, really rare. We have the sun, we have the moon, and yeah, maybe some lakes, but it's not very important for us and for our ancestors to find out about different sizes of those round objects. For height and length, or for height and width, for a rectangle, this is easy to do for us. We can compare values. So even if I don't know the numbers, we can guess that maybe Europe is a fourth from North America. So this is like, here's the half, so that's a fourth. And again, the Pacific would be a quarter, or like a third, a quarter to Europe. So this is easy to see. That would be really hard with pie charts. We can do ranking and histograms if we order and sort order this of the right amount. And we can also see the part of the whole. People tend to use pie charts for part of the whole, so how much percentage makes this or that. We can also build like column charts or bar charts and stack them. Then we also see like, this is like makes 10% of overall, or is more than half of the overall. So next time you're building pie charts, try first if you can build this with a bar or column chart. When should you use a bar and when a column? If the data is categorical, categorical data, I would recommend to use a bar chart. So like this, the horizontal bars with categories here. And if it's over time, then I would build columns. If you stick to this rule, then for the people, it's really easy to see without reading the axis. Now we are talking about time. Now we're talking about categories. Let's take a look what kind of categories. If it's columns, they don't really need to see the categories because they know it's over time. So try to find your own language within your charts and dashboards. Also, the column charts are not free of errors. So if I ask you again the same question like I did for the pie chart, which one of those elements, so 8 products, A to H, one is bigger than the other ones, which one? Then in live courses, people tend to not answer this question because this is so easy to see. They're not really there to answer the question because they think it's a trap or something like that. No. If you see this, A is the biggest one. If I ask you how much A is bigger than the other ones, again, press pause and think about it before I show you the solution. So people tend to tell me, nah, it's more than twofold, it's almost threefold because they count those lines here, and then we see it's almost 3 times as big. So A is almost 3 times as big as B. But the true answer is we don't know how much A is bigger than B because we do not see any axis, any numbers at the axis. So we don't know how much the numbers are, what numbers are we talking at. And if I show you the axis, then we see the axis is starting at 9.4. And 9.4 means that B, C, D, and so on are at level 10, and A is at level 11. And 11 is not 2 or 3 times of 10, but it's only 10% more. So what I try to tell you is always start your axis on 0. So rule number 1 is always start your axis on 0. Rule number 2 is in cases you cannot start your axis on 0, stick to rule number 1, which is always start your axis on 0. There's really rare exceptions where you would not start at 0. Try to really stick to this. Sometimes people complain and say, yeah, then the difference is really hard to see. Yeah, of course, if the difference is not very big, it's hard to see because the numbers are almost the same. If you really need to start it like in between to zoom in this, then try to really mark that the axis is not starting at 0. Unfortunately, Power BI, it's not possible to break the axis. I hope they're working on that and will come up with a feature like that. This is currently not possible, but really make it really clear if you're not starting at 0, because people tend to compare the whole length of the columns with each other, and if it's not starting at 0, then this comparison doesn't make any sense. The bar chart and the column chart, almost the same. Again, make it really easy for me. Duplicate the thing here and transfer this to a bar chart. As we have categorical data, I make a bar chart out of that, and here we have the bar chart. And then we have again North America, Europe, NA, and Pacific. And it's really easy to see that North America is the biggest one, as we have seen in the pie chart. We can also compare that Europe is like a fourth of North America. Take a look back to the pie chart. It's hard to see that this is a fourth of the other ones, if you ask me, but I could be wrong. The line chart. The line chart is meant for continuous values. So values which have continuous, like decimal numbers, they can change continually from one value to the other one. Or time can change rather continuously. So if you see this, then this is a line chart over time. I have the years here, but what I think, from one year to another year, this is not really continuously, because usually we have discounts or sales or whatever, like on a daily basis, every day, not just once a year. So it's not changing from one year directly to another year, but we have many days in between and weeks and months. So I would not consider this as a continuous axis if it's on years, because if I take the same numbers, so this is the same data, now I visualize this in line chart on year level. If I take the very same data and show you by date level, it looks like this. So back again to the year level, we have like an upwards, downwards, upwards trend. So this looks like positive or nice, because in the end we are rather higher than in the beginning. But if you look at the monthly level, like here, this is more continuously, then we see we have just spikes. So there's like a really flat line. Also in the end, it's rather flat, but there are spikes in there. And whatever the spikes mean, this is the true information we get there. If we put this on a yearly basis, we would hide this information. This is not a continuous going upwards or downwards trend, but it spikes within the years. And maybe we can expect this spike again in the next year or not. If you have like this data, put this not in a line chart, but put this in a column chart then. So it's not continuous because the columns are not connected to each other. Deviation is also a nice thing. Sometimes you see this with, for example, with Wall Street announcements. So they see like one index, two indexes are based on the same value, and then one goes up and the other goes down. In relation to the value at the very beginning. So it's not the absolute values, but the relation that what we see here. So for example, those numbers are going up in, if you assume this is months, so if you January to December, that's going up in February, going down again, spiking in November, and then going down in December again, and then it's going up to 100% again in January. So this would be a nice visualization if you're looking for changes and deviations over time. Correlations. So if we have here, for example, we can see that there could be a relation between the blue and the red line, because if the blue line spikes, also the red line spikes on top there or down there. So there's a sort of correlation in between the green line, whatever this is. There's not much correlation because that's not connected. Those upward trends there are not really connected to the other two lines. So there's no correlation here. Please do not line charts for nominals like northeast or something like that, or ordinals. So things which are not connected, use bar or column charts instead. I would prefer the bar chart because the columns I would reserve for year comparisons. Let's make a line chart here. We make a new line chart there. I have the line here, and then again I build one about sales amount by date, and then we get this wonderful line chart here. We see those upwards and downwards trend and can work with that. If I change this to a year level, change this to a visualization first, and then we can change this, for example, to see the years. Instead of the date, I would not put this on in a line chart. If you put the year here on the axis first, then this would be confusing because the picture on the date level looks rather different. So if you look on the year level, then I will put this in column charts. So there are columns. So we see the whole of the year, and that's not really connected. There's not so much of a trend in there. And if you look on the date level, I would make this a line chart. Portfolio scatter. This is very good if you have many values, like we have this overlapping here. You see like there's a dense area here and not so dense here, or there's a very dense area there. This is good with those kind of visualizations. You can also have more than two measures simultaneously. So I have the discount amount here, I have the cost here, and I have the size is the sales. So third measure is the size. So we have smaller sales here than we have here, and then we can see patterns. We can also add a time axis and then see changes over time in this and discover patterns which are not which are uniquely for one point in time, for example. What we're looking here is not for details, but for spikes. So we have like these outliers. They are something special. They're different than the other ones. So they have a higher discount than the other ones. Cost-wise, they lie in the middle, but for discount, they are outliers, for example. That's what we can discover here. And that's what I told you about the time axis. So now we are starting in 1st of July in 2011. Everything is flat, so we don't have any discounts. We have different costs, of course, of our products. And with 2012, we see that's a spike here. So this is the spikes about the discount. It's not for the whole time, but we have spikes in some points in time. That's what we can find out with this play axis. So scatter chart here. I select the scatter chart and then I will take the discount amount. So we have the discount amount. Here's the discount amount on, I think this was the y-axis. We had the cost. We had the cost. Where's the cost? Here's the standard cost. And the x-axis. And then we have the sales amount on the size. I put in the English product name. We have here the English category. Here's the English product name. That's the details and we want to see, and different colors for the categories. And no, I don't. I only want the products here, not the categories here. So we get all those values, and then we can add the date on the play axis. So we have the date here, and I put it down to the play axis, and then we see like these patterns changing over time. That's rebuilding there the chart. Get rid of the fields and visualizations. It's a little bit bigger here, and then we can play around there over time. Something's wrong here. Like in starting point, we have nothing, and then we can start the play, and then we will soon see values appearing. In 2003, what do we get here? There's something wrong with the play axis. I removed the play axis again here. Sorry for that. Obviously, I screwed something up in my demo file here, but here we could see like we have the spikes here, and when we hover over with the mouse, we can see that this is spikes. Product is touring 1,000, category spikes, standard cost is 1,000, discount is 1 million, 1,000 is standard cost, discount amount is 60,000, and sales amount is almost 2 million, 1.2 million. And last but not least, we have the map. And I try to stay away from maps because sometimes they are hiding things, or they're just showing obvious things, except for example the heat map. So we have like a soccer game here, European football, not the American football, soccer. And for example, we played in this direction. We see the red areas where our players spent most of the time. So they were not much here or here. There are also gaps here. And then we can see that we always proceeded, or mostly proceeded from this side. We can also see that the goalkeeper catch the ball, or if he could not catch it, it was deferred in this direction. And then we had corners played from here, not so much from here. So even we did not attend the game, we can learn something about the game. And the other thing is that we can also have massive data points in a map and see that there are massive points on this. I assume this is a street, and there's also gatherings there. There's more empty space there, and they could be interesting to find like white spots, literally white spots on a map to find out and gain insights. Please do not show simple data on a map, because usually, I mean, why should I put a world map to the people I'm working with? Because they know where Europe is, or US is, or Canada is, or whatever. Australia is, unless they do not know. So what we see here is this is Austria and Slovenia. Austria built a border, a fence on the border to Slovenia, and Australia is on the other side of the earth. And only if people have difficulties in distinguishing Austria and Australia, I would show them a map like CNN, which who had a problem in finding out or announcing that there is a fence between Australia and Slovenia. If you think about it, I mean, there's no common border, no country has a border with Australia, so why would Australia build a fence on a common border, which they do not have anyways? Next thing is display as few information as possible. This is like the term coined by Edward Tufte, chart junk. Avoid information, avoid things you do not need. So no useless decoration, show only information on the screen, and use proper scaling. So do not show like decimals if nobody is interested in the decimals. only show the numbers in millions if this is the interesting thing. For dates, only show the part of the date you really need. Don't show the time if this is not really useful for the users. Encode accurately. The most important encoding is the sort order, if you ask me. So people, at least in the culture I live at, is that they start reading from left to right, from top to bottom. And of course, the most important things should be on left top, because that's where people start reading. So in a dashboard, in a report, in every visual, show the most important stuff on left, show it on top. And the easiest thing to achieve this is sorting. This is really easy to do even in Power BI and other tools, sort the things. So to show the important stuff up there. Zero-based charts, we already heard about it. Start them at 0 unless you really have a reason not to do so. And reduce colors. So I tend to build really boring reports from a point of colors. So I stick to like shades of gray, not Mr. Gray, but a color gray. And this opens up because everything is really in gray to show afterwards the most important thing in a nice color. Also think about that around about 10% of the people are, 10% of men are colorblind, so they have difficulties in distinguishing red and green. So try to avoid having red and green on the same screen. You can use red, you can use green, but don't make it an important distinguish for warnings or something like that, but coloring the things in red and green. Take red and blue or blue and green. If you want to find out more about color blindness, there's this fabulous site explaining everything about color blindness, and you can also upload your dashboard there and see it with the eyes of somebody who is colorblind, as we will see next slides. If you're not sure what colors to choose, one really cool site is Color Brewer. Check this site out. There you can ask for different colors for different meanings, and also click a check button there to say, please give me colors which are also useful and distinguishable for colorblind people. So this is the pie chart, the original, and for everybody who is able to see all the colors, a reminder, there's red in the left upper corner, green on the right, and blue in the bottom left corner. That's the colors. And then I uploaded this chart to this colorblind page and transformed it to somebody who suffers of deuteranopia. So they have trouble to distinguish red and green, and you can see this is like this pie chart would look like for this person. Still, they can distinguish the red and the green, not because of red and green, but because of the darkness or lightness or the hue of the color, you would say. But this could be different for other kinds of red and green, so please be careful with that. With protanopia, it's even easier for them because they can better distinguish this kind of red and green, but still, there's no green, there's no red for this person, it's only brownish. Well, people, which is really rare, tritanopia, they have troubles with distinguishing blue and green, as you can see here. Again, on this particular slide, they could distinguish the things, but depending on different hues of blue and green, that would be way harder for them. So avoid having those colors on the same side. As I said, tritanopia is really rare. Check out with the people you're working with if this is an issue. Red-green is a much bigger issue. 10% of males have this. After we have reduced everything, it's easy now to enrich the thing. So for example, we got rid of all the icons and fluffy and colorful things which do not bear any information. We can then put a text there and telling people this is what they're looking for. Or we could use then color, because now everything is very simplified now. We can use colors to highlight important things. We can use icon set spots or a data bar to show stuff and highlight things for the people, what they're looking for. And a data bar in Power BI is already easy to build. If I go back to my table and duplicate this page there, so I got my duplicate here. So in a table there, you can always change in the format options a conditional formatting, and can then choose you want a conditional formatting for the sales amount. So that's the number column here, not the totally so sales territory group, but the sales amount. And then we have different possibilities. So you can build a heat map with the background color. So the color changes with the amount of value. What I prefer is a data bar. So if you turn this on, we get a bar within the table. So we're combining both goodnesses from both worlds. So we are on the one side, we have the advantage of a bar of a table, which shows the precise number. We can have different scalings with the nice feature of a bar, which shows with one look that North America has the biggest value. We don't have to read the number. We just see that the bar is full. So this is the biggest one, and those are way smaller than the other one. And then you can also change the controls here, advanced controls. Then you change the color and how this is built up by having a choice here. What's the positive bar? If it's negative, choose different numbers, or you can also set the minimum and maximum hard-coded and not be found out by the different data provided in the visual. Calculate measures. This is like to add different stuff. So if we have, for example, a discount amount at the percentage and people are interested in what was the change from one year to another, then it's really stupid if they have to like export this to Excel or take a pocket calculator and find out. Really put this there. You have DAX available in Power BI to calculate stuff. Unfortunately, I'm running out of time, so I cannot show this calculation, but there's a lot of information out there about DAX. So it's easy to learn to calculate stuff there. So you will start off rather soon in calculating discount delta, for example. So we see the difference between those years, so a positive or negative change over the years here. So again, they're good. I hope you now know why I think this is a good visualization and tables are cool visualizations, why this is bad or the other one is bad. And I mean, I say this is bad, but how could you build this better? This would be a better visualization. So there's the same numbers. We have the categories here. The number was the discount percentage I did show you. And then you see here, like this was the 1.79 number, if you can remember that. It was the other numbers. That's how I would visualize the discount percentage, not as a pie chart, not as a ribbon, a 3D line chart, because there's no connection between. This is what I would suggest on this point. So call to action, before I'm really running out of time, check all the chart types you're using. So go through your reports, go through your dashboards and take a look. Are those really the chart types? Are those useful for what people are looking at? Then reduce as much as possible color-wise all the colorful things out there on your report or dashboard. Remove everything, and then you have space to enrich it. Add those calculations people are asking since several days or weeks, and there was no space for it. And again, use the proper chart type. Display as few information as possible, as much information as necessary. Encode accurately. Highlight the important things and calculate the measures. If you have reduced everything, it's easy to enrich then the report for the stuff people are looking for. Yeah, anything about not only Power BI, but everything on Microsoft stuff is on docs.microsoft.com. Check this out. There really good documentation out there. If you got more questions, then you're more than welcome to reach out to me. Here's my email, my Twitter, LinkedIn, and yeah, let me know if you're interested in some sample files I can send you over, or if you got any questions, then just let me know. With that said, are there any questions from my attendees in this live seminar? Doesn't look like that. Then I say thank you very much for attending this live seminar and all watching the recordings. And yeah, see you soon in another expert talk here at Skill Me Up. Bye-bye.